Welcome back to Geology Dean's Masterclass. Last time, we introduced the world of sedimentary rocks. Today, we're going back to the very beginning, to the birth of sediment itself. And it all starts with a process called weathering. So, what is weathering? Simply put, it's how rocks at the Earth's surface are broken down and altered. Think of it as nature's demolition crew, constantly at work. There are two main types of weathering, and they often work together like a tag team. First, we have mechanical weathering. This is the physical breakdown of rocks into smaller pieces without changing their chemical makeup. Imagine a large boulder. Over time, fractures can form. Water seeps into these cracks, freezes, expands, and wedges the rock apart. This is called a freeze-thaw cycle. Another way is through thermal expansion, where daily heating and cooling cause the rock to expand and contract, eventually leading to cracks. The key takeaway is that mechanical weathering is all about reducing size and creating more surface area. Now, why is more surface area important? Because it sets the stage for our second process, chemical weathering. This process changes the actual mineral composition of the rock. Let's look at three key mechanisms. First is dissolution, where minerals like salt or calcite simply dissolve in water. Think of how sugar disappears in your coffee. Second is oxidation, which is basically rock rust. When minerals with iron are exposed to oxygen, they rust, creating those beautiful red and yellow colors you see in many landscapes. Finally, there's hydrolysis, where water reacts with minerals like feldspar to form new clay minerals. These two types of weathering are a powerful duo. Mechanical weathering breaks the rock apart, creating tons of new surfaces for chemical weathering to attack. In turn, chemical weathering weakens the rock, making it easier for mechanical forces to break it further. The end products are tiny rock fragments, new clay minerals, and dissolved ions in water. These are the raw materials for all future sedimentary rocks. Climate plays a huge role in which type of weathering dominates. In warm, humid places like a tropical rainforest, chemical weathering is king. The constant moisture and heat speed up chemical reactions. In contrast, cold regions with lots of freeze-thaw cycles or dry deserts with big temperature swings are dominated by mechanical weathering. Understanding weathering is crucial because the processes that break down the parent rock determine the size, shape, and composition of the sediment. This, in turn, influences how that sediment is transported and what kind of sedimentary rock it will eventually become. That's our look at weathering, the essential first step in the life of a sedimentary rock. Join us next time as we follow these newly created sediments on their journey. Thanks for watching, and don't forget to subscribe for more geology insights.